All right, so here we're going to do some calculations with functions. We're going to add, subtract, multiply, divide, and we're going to composite them. So you can see that in order. And the two functions we're going to use are this f of x equals 2x plus 5 and g of x equals x squared minus 9. And we also talk about domain in certain instances. So anyhow, A, it's asking you to add these two functions together. F plus g of x is the same as f of x plus g of x. So you're just taking f of x plus g of x, and then combining like terms and putting them in the proper order. So this would be x squared plus 2x plus 5 minus 9, which is negative 4, and we're done. Simple. Now B is a similar question, but we're subtracting. So f minus g of x would be f of x minus g of x. Here you have to be very careful. So f of x is 2x minus 5, or 2x plus 5. And you're subtracting now g of x. You're subtracting the entire g of x. So use parentheses so you will remember to distribute this minus. Or you can make it plus a negative and distribute the negative. Either way, you get 2x plus 5. Now here comes the distribution. Minus x squared and minus a negative 9 or plus 9. And then just like the last problem, put them in order of terms. So negative x squared first, plus 2x, plus 14. So that was addition and subtraction. Pretty simple. C and D are multiplication and division. Also pretty simple. So C says to do f times g of x, which means f of x times g of x. So you just multiply f of x times g of x. So I'm going to multiply these together. I'm going to use foiling. So first, 2x times x squared outside minus 18x inside plus 5x squared. And finally, last, 5 times a negative 9 is negative 45. I'm going to reorder the terms. 2x squared plus 5x squared minus 18x minus 45. And there you have it. Next is division, f over g of x. I'll do that right up here. F over g of x means f of x over g of x. So it's 2x plus 5 over x squared minus 9. Now, you don't divide those, because, especially since the bottom degree is bigger than the top. It's a proper fraction. I am going to talk about domain, though, because we do have division, and you know you can't divide by 0. So this is the answer. The domain, and you can see it, is the bottom can't be 0. So x squared minus 9 can't equal 0. We're going to find out when it does equal 0. I'm going to do it by adding 9, square root both sides. When you square root both sides, you need a plus or minus. So x equals plus or minus 3. Meaning that's the two numbers that would make the bottom 0. So the domain of this function would be anything but those two numbers. So the domain is x cannot equal plus or minus 3. And finally, I'm going to take care of the compositions. So that's E and F. Compositions, the order most often matters. So let's take care of E first. F of g of x It's better written as f of g of x like this. I like this notation because you always do the inside function first. So you can see g of x is inside. So what I'm going to do is I'm going to plug in g of x, which is x squared minus 9. Now this says f of x squared minus 9, which means look at the function f, and anywhere there's an x, plug in x squared minus 9. So that means here's f. I'm going to plug in x squared minus 9 in for this x. So the 2 doesn't change. This x becomes x squared minus 9. And then I have that plus 5. Simplify by distributing the 2. 2x squared minus 18. And then negative 18 plus 5 are like terms. You add them together, negative 13, and we are done. Finally, f should be very similar, except f is g of f of x. So that tells me I'm going to start with f of x. F of x is the inside function, and f of x is 2x minus 2x plus 5. I need to plug this in to g. So anywhere there's an x in g, I have to plug in 2x plus 5. So g is x squared minus 9. So instead of x squared minus 9, it's 2x plus 5 squared minus 9. I'm going to square this out with a square double square for x plus 2 times 2 times 5 is 20 plus 25 minus 9. And oops, I forgot my square here. And then combine like terms. So plus 20x. 25 minus 9 is 16. Is that right? And there's my final answer. That's it.